start this. Okay. So the topic of today is projectile motion and relative motion. Okay. So like both of these things belongs to two-dimensional and one-dimensional motion. Okay. Yeah. So like till now, whatever you have discussed, whatever you have learned, just all those fundas are going to be applied over here, depending upon whatever you have learned. Okay. Means I'm going to utilize every concept. Okay. So please look into this because this part, the theory part is okay. Means you will be able to understand projectile motion and relative velocity in a very good way. But what after that? Okay. If you will be approaching the problems, there are 6 different kinds of relative motion problems. Train, after that rain and man, after that man, umbrella and rain, after that man in a boat. Okay. A person swimming inside the river, all these kind of problems, all these kind of concepts are there which are going to be utilized. Okay. And they are based upon all the things which I am going to do today. And after that, projectile motion, it is the most easiest topic, but it will be like initially the theory part will be today, it will be easy, but day after tomorrow when I'll be including the questions and all, then it will be very much hard. Ma'am, can you just switch on the internet? Okay, it's not there. Okay, no problem, no problem, thank you, ma'am. Okay, okay, so should I start? Hey guys, can you hear me now? Okay, come in. Now be silent. Okay, now look over here. So I'll first start with relative velocity. Okay, my hands are a little bit okay. It's so many days I have utilized it. Like it's been like 7 to 8 days I'm touching this graphic tab. Relative motion. So first topic is relative motion. Now look over here. See this. Hey, who is this? Be silent. Okay. You do not laugh, guys, because in recording the sounds are not included. Okay. The desktop sounds are not there. Only mine sound will be accepted. Do not laugh and all. Okay. So look over here. Okay. So you are aware of position vector? What was that? So let us consider. See, first I'm taking an example. So there is the particular, try to understand this example. Okay, you have one particle over here. Okay, now let's suppose this is our Hemant. Okay, walking on the road. Hey, who is that guy? Okay, now look over here. See this. So let's suppose if we have one person walking on the ground. Okay, there is one tree. Okay, one person is sitting over here. One person is sitting on the tree. Another person on this particular road. There is one car. Okay, and in this car, one another person is there. There are 3 persons over here. Okay, who is that? Marine. What? Hello? Okay, now look over here. So you try to understand. Let's suppose there are 3 persons. Okay, how many persons I have taken? 3 persons. One who is walking on the road. Let's suppose it has velocity v towards right side. One person sitting on the branch of a tree. Okay, at rest. Its velocity is how much? 0. There is another person. Let's suppose I call this as person A. Velocity of A is 0. Velocity of B is something towards right. Okay, and there is another person who is sitting in the car, and this car is driving. Let's suppose this car is moving in the opposite direction with some kind of velocity of c is equal to velocity of v prime. Okay, 3 persons are there. What I'm saying, 3 persons, one walking on the road with some velocity v, another person sitting on the ground tree whose velocity is 0, another person who is sitting in the car, and that car is moving with some kind of velocity v towards the left side. Now, I'm trying to observe this phenomena. What I'm doing, I'm trying to observe this phenomena. So let's suppose if this person, the person who is sitting on the tree watches this person, what he is going to tell? That this walking person is moving with its original velocity v or not? Tell me yes or no. Or yes or no, guys? 100%. Now, but if this car person, or let's suppose if this person who is walking towards right with some velocity v, if this person, let's suppose he is some kind KTM wala guy and there is Sundar Kanna in this car, okay? So now let's suppose, see, if this KTM guy watches that Sundar Kanna, what he is going to observe? Is that Sundar Kanna is moving with some kind of extra velocity or not? Tell me yes or no. Or yes or no? Definitely. Why it is happening? Why it is happening? Although they have the respective original velocities or not. So on in the first class, in the main first class, I told about one thing that is called as a reference point and a specific point. Yes or no? I talked about that or not? And this is the one biggest contradiction. It depends. I told that time that it depends upon your reference point. Whatever. Let's suppose here, if I select this as my reference, this is stationary. So with respect to this, we are calculating the velocity and we got the original velocity of the body. But since this person is moving and this person is also moving, I consider this as my reference point this time. What will happen? I told you now that day, if you make the reference point move, your answers will become different. Or yes or no? So what happens actually in nature, that the person who is at rest can calculate the things very easily. The person who is in the motion, the physical concepts changes. What happens? When the objects are in motion, the physical concepts changes. Now, one thing is very much sure. Everything is means in physics, this particular concept of relative motion or this particular approach was brought by Albert Einstein. Who brought this? Albert Einstein. Actually, like Newton's, everyone, Newton's, Galileo, Copernicus, all these persons who are big, great scientists actually dealt with something called as inertial frame. But what they deal? Inertial frame. Now, what are called as inertial frame? So you try to see this. This person who is sitting on the particular tree is at rest or not? Tell me yes or no. To measure the velocity of this person, what we need to do, since I am considering this person to be at as a reference frame, I need to draw the coordinate axes over here or not? Or yes or no? With respect to this coordinate or with respect to this frame of references, I can calculate the velocity of this person or not? Tell me yes or no, guys. Or yes or no? So then, these frame of references for which the observer is at rest is called as inertial frame. What it is called as? Inertial frame. Because why it is called as inertial frame? Because for this frame, the answers will be perfectly accurate. The answers will be what? Perfectly accurate, and it will be perfectly correct also. But when this particular person starts to move with some kind of velocity, and if I draw some frame of references on these kind of frames which are called as moving frame are called as non-inertial frame. What they are called as? Non-inertial frame. So you might have heard in the units and dimension, inertia. I talked about inertia or not? Tell me yes or no. These properties came from inertia only. So for every inertial object, what is going to happen? Like you try to understand, if I am on the earth, if I am standing over here, I can measure the different cars moving from my, like if the cars move in front of me, I can measure the velocities and all. But if I go to moon, what will be observed? That I am also revolving or not? Tell me yes or no. Or yes or no. So at that time, what is going to happen? Your velocity will change or not? Tell me yes or no. So this is the concept he brought, Albert Einstein, that nothing is perfectly at rest. Whatever you are considering, all the motion, all the graph which you are watching, I'm drawing it for the rest condition. I'm taking that initially the particle was at rest. But with respect to what it is at rest? Yes or no? It is a big question or not? With respect to what it is at rest? If I'm saying that this bag is stationary over here, or if this particular whatever I have written is a stationary over here, it is a stationary with respect to what? It is stationary with respect to ground, with respect to my eyes, with respect to some observer. If I take this observer on the moon, he is going to watch that this laptop is revolving, this bag is also revolving. So actually your answers, your question answers, your way of motion changes when you change the observer. What happens? When you change the observer, the concept is simple. When we change the observer, the equation of motion changes. Okay. What is going to happen, guys? When you change the observer, equation of motion is totally going to change at that time. Yes, you need to write. You guys need to make these points, okay? Uh-huh. Example. Yeah, example. It will again come. It will again come. Wait. That was just the theory. Why we are considering relative motion, okay? The frame, the frames of references which are at rest are called as inertial frame. Are called as inertial frame. The frames which are moving, the frame of references which are moving are called as non-inertial frame. Okay. These are the three main basic important points. Okay. Online, everyone is here. Okay. Yeah. Done. Right fast, guys. Vinay. Okay. Can I move ahead? Can I move ahead now? Okay. Now look over here. Now we are going to the mathematical view of it. Okay. So now look over here. Let's suppose you try to see this perfectly. You might have done it, but you'll get confused over here. Okay. But do not get confused. Okay, I'm not drawing that 3. Okay, I'm not taking that 3D axis. Okay, now look over here. This is your x axis. This is your y axis. This is your x prime axis. This is your y prime axis. First thing, okay, there are two coordinates. What I took, listen this perfectly. There are two coordinates. Okay, means how many observers are there? Can you tell me? Two observers, definitely. Yes or no? At every observer, I need to draw frame of references or not? Okay. So if I have drawn this frame of references, that means what? At center, we have one observer O, and here we have another observer O prime. Got it or not? I'll tell you the meaning why I am doing this. Okay. Now let's suppose. So let's suppose you try to understand that there is particular road. Okay. On this road, there is one person who is walking towards the right side, and then there is your car in which one person is there. Okay, and this car is also walking towards the right side, and then there is a tree. Okay, and here one person is there. Three persons are there. one person is moving. Okay, now I want to talk what I told. I want to talk about the motion of this person who is moving towards the right side. Okay, so tell me one thing, this will be called as a specific point or not, guys? Or yes or no? What is a specific point on which you do the measurement? So this will be called as a specific point. Got it or not? Are got it or not? Now, the velocity of this particular person can be determined with the observer sitting in the car or not? Tell me yes or no? Or yes or no? So can I say that the observer who is sitting in the car will be called as moving observer? Or yes or no? Guys, yes or no? Can I call that observer in the car to be as a moving observer? Got it or not? Next, you have another observer. You can also determine the velocity of this person with respect to this observer, and this will be called as which kind of observer? A stationary observer. What I'm calling this, guys? A stationary observer. Okay, but you try to understand one more thing. With respect to the stationary observer, I can determine the velocity of the moving observer or not? Or yes or no? So what I'm doing, I'm trying to establish one connection. What kind of connection? I'm trying to establish three connections. One, the connection between the moving observer and the person who is walking. Second, the connection between the stationary observer and the moving observer. And last, the connection between the stationary observer and the person who is walking. Are you able to get me or not? So three kind of connections I'm trying to establish, and I'm trying to represent them on coordinate axes. So let's suppose this person who is walking with velocity v, I'm calling this as a particle over here, okay, which has some kind of velocity towards this side. Okay, I do not know what kind of velocity. Okay, so let us first erase this velocity. Let us do not know, or we are not aware of the amount of velocity, so we are just erasing this. Okay, now you try to see, I can draw one displacement vector from, or sorry, one position vector from O prime to P or not? Tell me yes or no, guys. Or yes or no? Can I draw one position vector from O prime to P? This is what? This position vector is representing what? Displacement of P with respect to which axis, guys? With respect to O prime observer. Got it or not? So you try to understand. See this. Can anyone explain me what is RPO prime? What I have written? Little bit. Any idea? What is that? Distance of particle from which observer? Moving observer. From which observer? Moving observer. We are considering that this particular coordinate y prime and x prime is moving with some kind of velocity v over here. Okay? Is moving with what kind of velocity, guys? Some kind of velocity v. Got it or not? Got it or not? So now try to see this. This O prime will become a moving observer or not? 100%. Chaitanya, okay or not? Sit straight. Okay. Now look over here. Now, this O prime is also moving with respect to O or not? Or yes or no? So can I draw one position vector to connect between O prime and O? Tell me yes or no? Or yes or no? So this position vector will be called as what? Distance of R of O prime with respect to what? O. And what does it is representing? It is representing the distance of moving observer with respect to the stationary observer. Are you able to get me or not? Everyone, are yes or no? This is the biggest point what I am doing. Now you try to think, I can actually find, you try to see what I have done. See this. Actually, what I have done? I first find out the distance of this particular person with respect to this car. Then I find out the distance of this particular car with respect to this particular stationary observer. Then I find out the distance of this particular person with respect to the stationary observer. Can I do these three things or not? Tell me yes or no? Or yes or no? So now look over here. So I connect, if I connect this line with the P, okay, I'll connect with a black, okay. So this particular line will represent the distance of the particle P with respect to which observer? A stationary observer. Got it or not? Are I got it or not? I'm calling this as distance of particle P with respect to the stationary observer. Now you try to see this. All of these are vectors or not? Or yes or no? Can I calculate? Now you try to see. I'm erasing this example, okay? Now I am purely in mathematical form. Now you try to see, is this is a displacement resultant vector? Yes or no? R PO prime? Yes or no? Okay. Now what is the formula? R vector of PO will be equal to what? This head and head are matching or not? Set. Wait.